Well, hello everyone. Welcome to our channel 361 Physics, and here we are presenting our second video of uh, elasticity part 2. Okay, so this video is totally based on MCQ problem. So let us begin with first question. And in the first question it is given that in the given this is an okay, so in the given figure the load versus extension curve of two wires A and B are drawn. The dimensions of wire are same, but they are of different materials. Okay, so it means uh, they have different Young's modulus. Okay, the Young's modulus is more for, so we have to find here which of these two wire uh, have greater value of Young's modulus. So just we have to recall the formula of Young's modulus, and this is equal to stress. That means we can say this to be as a load, okay, load per unit area, and strain. So it means load per unit extension gives us the Young's modulus, and also we know that Young's modulus is the slope of uh, load versus extension curve. Okay, that means if the slope of a particular curve is more, so it directly represents that curve or that material having the that kind of curve uh, has maximum extension, sorry, maximum Young's modulus. Okay, so let us find out which of them have minimum slope, or we have to find here more, that means which of them has maximum slope. So from this figure we can easily say that uh, this A material has maximum slope for load and extension. That's why we can say uh, A material uh, has maximum Young's modulus. Okay, so actually फेरि भनिदिउँ, यो क्वेशन्सले भन्दैछ यो लोड र एक्सटेन्सन बिचको रिप्रेजेन्टेसन हो र यसमा मेटेरियल ए एन्ड बी छ। मेटेरियल ए र बी को एउटा कर्व देखाएको छ यो ग्राफ, एन्ड हामीलाई सोधेको छ ए और बी मध्ये कुन चाहिँ म्याक्सिमम यंग्स मोडुलस हुन्छ। कन्डिसन के हो, वायर को सेम लेन्थ छ, डाइमेन्सन सेम, मतलब लेन्थ डायमिटर सबै सेम छ, मेटेरियल फरक हो। ओके, सो हामीलाई के थाहा छ भने यंग्स मोडुलस इज द रेशियो अफ स्ट्रेस, यसलाई हामी लोड भन्न सक्छौं, टु द स्ट्रेन, यसलाई एक्सटेन्सन पनि भन्न सकिन्छ। र स्ट्रेस टु द स्ट्रेन को ग्राफ को स्लोपले हामीले दिन्छ यंग्स मोडुलस, र स्लोप जसको बढी त्यसले हामीलाई बढी यंग्स मोडुलस को भ्यालु दिन्छ। त्यसैले अब इजिली हामी हेर्न सक्छौं बी को स्लोप ए भन्दा कम छ, अर यसरी भन्दा नि हुन्छ ए को स्लोप बी भन्दा बढी छ, त्यसैले ए मटेरियल को यंग्स मोडुलस को भ्यालु म्याक्सिमम हुन्छ। त्यसैले अप्सन ए हाम्रो करेक्ट अप्सन हुन्छ। Okay, so this is all about question number first, and here we are in question number 2. A wire of length L and radius R has Young's modulus Y. If it is stretched to make its length twice of original length, then its Young's modulus will be. So simply बुझ्नुपर्छ है, we have to understand that Young's modulus particularly depends upon the nature of material. Which means that by increasing the length or decreasing the length, there is no impact in this value. Okay, so length increase गरे पनि, length लाई decrease गरे पनि त्यहाँनिर यंग्स मोडुलस को भ्यालु चेन्ज हुँदैन। यदि मटेरियल चेन्ज गर्ने भने अफ कोर्स हुन्छ। त्यसलाई हामीले कन्क्लुड के गर्छौं, we can conclude that its answer is first, the value of Young's modulus remains same. Okay, so यो बुझ्यो होला। अब हामी question number 3 मा छौं. Two wires are of same radius and material and they have their lengths in the ratio 1:2. If they are stretched by same force, the strain produced in two wires will be in the ratio. Okay, so अब first of all हामीले यो वर्डलाई एकदम मजाले बुझ्नुपर्छ. Same radius and material. Same radius and material means, or simply same material means, they both of the wire has same Young's modulus. Okay, I am going to suppose the Young's modulus of first wire as y1 and Young's modulus of second wire as y2. Then we can equate these two. Now, as we know that stress, okay, and strain, the ratio of stress and strain makes the Young's modulus. This is all about for your first wire, and the ratio of stress and strain is once again the Young's modulus for second wire. Now, as we know that the value of stretched shear, the value of force applied are same. That means force applied are same, which means that stress is also same. Why? Because force per unit area provides us the stress. Force is same as well as the diameter or radius are same. That means for both wires stress is same, so we can easily cancel out these two. Okay, now we are going to uh, conclude this. So strain in first wire becomes equal with strain in second wire. Okay, and we have to find here the ratio of strain produced. So it means the ratio of strain produced must be 1:1 because they are equal. फेरि बुझौँ, दुईटा वायर छ, सेम रेडियस छ, material same भन्न साथ हामीले यंग्स मोडुलस इक्वल लेख्न सक्छौं. They have their length in the ratio original length 1:2 छ. If they are stretched by same force same छ, strain produced को रेशियो निकाल्नु छ. हामीले एजम्पसन गर्यौं y1 and y2 दुईटाको यंग्स मोडुलस हो. स्ट्रेस टु द स्ट्रेन हामीसँग फर्मुलेसन छ यंग्स मोडुलस को. हामीलाई थाहा छ स्ट्रेस भनेको फोर्स पर युनिट एरियाको रेशियो हो, अनि फोर्स अप्लाइड सेम भनेकै छ सी, एन्ड रेडियस अलरेडी सेम भनेकै छ हैन, रेडियस पनि सेम छ. त्यसैले हामीले यो क्वान्टिटी स्ट्रेस क्वान्टिटी चाहिँ के छ कन्स्ट्यान्ट एजम गर्न सक्छौं. या त्यसैले स्ट्रेस applied in both of the wire are same, so we can easily cancel these two. अनि त्यस पछाडि यसलाई क्रस मल्टिप्लिकेसन अर डाइरेक्ट हेर्दाखेरि पनि हामीले के पायौं भने स्ट्रेन एन्ड स्ट्रेन फर फर्स्ट एन्ड स्ट्रेन फर सेकेन्ड वायर आर सेम. सो यसलाई रेशियोमा हामीले लेख्ने भने 1:1 हुन्छ. Okay, now we are going to discuss question number 4. Two bars A and B of circular cross section and of same volume made of same material are subjected under same tension. If diameter of A is half that of B, the ratio of extension of A to that of B will be. Okay, so let me adjust this because I need some space here. Okay, so according to question, we can say that the Young's modulus of first and second bar are same because here is mentioned same material. So I'm going to make first here expression, okay, an expression, and then we can easily use that expression for overall cases. So here I'm going to write the Young's modulus as force per unit length and force times L, that means original length, and it can be written as here we should write here area, that's why pi d square by 4 we can write here a cross sectional area, and this is extension del x or del L. So it can be written as y, okay, y equal to 4 times FL by this is pi d square upon E extension, and we have to introduce here the one term, see volume. Yeah, same volume. So as we know that volume is the product of cross sectional area times length, so we can easily write here pi d square by 4, and then this is length. Okay, so to introduce the value of expression or just volume, we can say that we just have to write it as b by pi d square by 4 times sorry, this is not times, equal to L, and now we have to replace this L by b upon pi d square by 4L. So will be it will be like y equal to uh, 4 f L by pi d square. Let me drop this L. Okay, pi d square, and this is extension multiplied by v by 4. uh, okay, this is not 4, pi d square, and this 4 will go here, so it will be like y equal to 16 b by pi square d4 and extension. Okay, so uh, in terms of extension, okay, in terms of extension we can write it as extension equal to 16b by, okay, y pi square d4, 16b by y comes here, y pi square d4. So from this all we can conclude that 16 is constant, b is given constant, this is what, this is y, Young's modulus is constant, pi is constant. That's why we can easily make one interrelation, that means um, extension is inversely proportional with the uh, diameter, fourth power of diameter. So we are going to use this expression to solve this equation. Okay, so let me drop this part. Okay, so now we can easily write the expression as E1 is to E2 equal to D24 by D14. Okay, now here it is given if the diameter of A is half of that of B. So this is the diameter of B, and here I'm going to write that half of diameter of sorry, diameter of A as half of diameter of B, that means D2 by 2 and its whole power 4. Okay, so it will be like D to the power 4, and then 16 will be here, yeah, and then after it will be here, these two will cancel out and the answer is 16. Okay, so let me check whether there is option or not. Yeah, in D we have the option 16, so our correct option is 16. Fairy Bandhu, two bars A and B of circular cross section of having same volume, same material, maniko gamma ko kura garyo, and subjected under same tension. If diameter of A is half that of B, the ratio of extension of A to the that of extension of B. So हामीले कम्प्लिट डेरिभेसन नै गर्यो यो रिलेसनको, तर अब डाइरेक्ट फर्मुला याद राख्दा हुन्छ, एक्सटेन्सन इज इन्भर्सली प्रोपोर्सनल विथ द फोर्थ पावर अफ डायमिटर, अर एक्सटेन्सन इज इन्भर्सली प्रोपोर्सनल विथ द फोर्थ पावर अफ रेडियस. के यो फर्मुला सम्झिँदा हुन्छ अब डाइरेक्टली हामीले डिराइभ गर्यौँ, किनभने कहाँबाट कसरी आउँछ भन्ने कुरा जान्नु पनि पर्छ. कुनै समयमा यो फर्मुला एक्ज्याक्टली याद छैन भने हामीले रफली क्यालकुलेसन गरेर पनि सल्भ गर्न सक्छौँ. So our extension of first को inversely relation यसरी लेखेको so extension of second को inversely relation and second को sorry first wire को diameter second को half भनेको छ that's why यहाँ d2 by 2 लेखेको अनि solve गर्दाखेरि 16 आयो so option 16 correct option हुन्छ. Okay, so this is question number 5. A ball falling in a lake of depth 200 meters shows a decrease of 0.1 percentage in its volume at the bottom. What is the bulk modulus of the material of the ball? Okay, so bulk modulus, as we know that bulk modulus B or K कुनै वेमा रिप्रेजेन्टेसन गरिन्छ is equal to del P मैले यहाँ नेगेटिभ साइन लिइन म्याग्निट्युड मात्र युज गर्यो del V by V. So this is change of pressure or stress. 200 मिटर डेप्थमा जानु भनेको हामीलाई थाहा छ के लाग्छ त्यहाँनिर लाग्छ HDG. This is the change of pressure. त्यसैले हामीले यहाँ लेख्न सक्छौँ HDG and this is what this is this parameter decrease of 0.1% of its original volume or volume. So this is 0.1%, so it can be written as 0.1 by 100. Now we are going to write here 200 height is given, dimensions, density of water it is not provided, but we know that this is its value is 1000 and value of G is 9.8 and this is 0. Okay, I'm going to write 100 here, so it will gives us let me write here 100. Okay, so I think space is not sufficient, so I'm going to write here 200 times 1000 into 9.8 into 100 divided by 0.1. Once again this 0.1 also can be written as 200 into 1000 into 9.8 into okay and into 110 and it will be 1 after multiplying this value as well as denominator value by 10. So on multiplying we'll get a particular answer. I think its answer might be D or C. So it is your work, so find out its value and please write it in your comment box. Okay, so so that we can make the judgment whether that answer is correct or not. Okay, so this is all about the solution of question number 5. फेरि थोरै भनिदिउँ ball falling in a lake of depth 200 shows a decrease of 0.1% in its volume at the bottom. What is the bulk modulus of material of the ball? So bulk modulus लाई generally B or K ले representation गरिन्छ. यो माइनस साइन हुनुपर्ने दिएको छैन because magnitude by its solution गर्दैछौँ. del P by del V by B हुन्छ. del V by V को value 0.1% हो. That's why हामी easily लेख्न सक्छौँ 0.1 divided by 100. and del P भनेको present pressure भन्न पनि सकिन्छ. अब हामीलाई थाहा छ बललाई राखेको छ सर्टेन डेप्थमा, त्यसो भए यहाँनिर लाग्ने प्रेसर अर चेन्ज अफ प्रेसर भनेको HDG हो हैन. अनि सो HDG अप्लाई गर्यौं एन्ड देन रेस्ट अफ द थिङ जस्ट म्याथमेटिकल क्याल्कुलेसन गर्यौं र यो एन्सर निकाल्ने र एकचोटि कमेन्ट बक्समा हाम्रो लेख्ने कुन चाहिँ करेक्ट हुन्छ हामी त्यसलाई रेस्पोन्ड गर्छौं. Okay, so question number 5 completed. Now we are in question number 6. A wire unloading with a weight of mg extend in length by L. The work done in this process is. So this is quite simple. Work done or extension during extension is stored in the form of energy. So the expression for energy is F and this is extension. Okay, so this is extension. Well, and here is given the value of extension is L, so 1 by 2 F times L. The wire is wire is attached with load uh, of mass M, and its weight is mg. That's why the tension or force applied in this particular wire is this one, F, mg. So we can easily replace F by mgl. So this is our correct answer. So we can easily see the expression is in A. So A is our correct option. Well, we are now in question number 7. The elastic deformation energy per unit volume in freshwater compressibility beta at a depth of h below the surface is, okay, now we have to know that uh, bulk modulus and compressibility are reciprocal with each other. Also we have that expression for energy stored, okay, energy stored per unit volume is 1 by 2 stress times strain, and this is volumetric stress, and this is change of pressure for the case of bulk modulus. So 1 by 2, and this can be written as del P and strain as del V by B. Well, from here we can easily write K as del P by del V by V, which means this is equal to del V by B by del P. Okay, now so from here we can find the value of del V by V, which is equal to beta times del P, and now we are going to use this expression here. So it will be like uh, 1 by 2 del P, and once again del P, this will be square, and then beta. So this is del P times del P, that means change of pressure, and it is given here, it is the object uh, is placed in water, that's why the change in pressure is hdg square and beta. So I think again first option is, yeah, correct option. So option A is correct option. This is correct option. फेरि भन्दिउँ यहाँ के भनेको छ भने डिफर्मेसन एनर्जी पर युनिट भोल्युम अफ फ्रेश वाटर कम्प्रेसिबिलिटी बिटा भनेको छ एट अ डेप्थ अफ एच बिलो द सर्फेस डेन्सिटी अफ वाटर दिएको छ। हामीलाई थाहा हुनुपर्छ कति ठाउँमा बल्क मोडुलसलाई रिप्रेजेन्टेसन गरिन्छ, कति बुकले केले रिप्रेजेन्ट गरिन्छ। मैले अब क्वेसन अनुसार यो कम्प्रेसिबिलिटी हो, यो चाहिँ बल्क मोडुलस हो, जसको एक्सप्रेसन डेल पी बाई भी हुन्छ। यहाँबाट डेल भी बाई भी डेल पी लेख्न सकिन्छ, एन्ड डेल भी बाई भी बिटा टाइम्स डेल पी लेख्यौँ। अर्को भनेको एनर्जी पर युनिट भोल्युम भनेको हाफ स्ट्रेस टाइम्स स्ट्रेन हुन्छ। स्ट्रेन स्ट्रेस फर लिक्विड को केसमा चेन्ज अफ प्रेसर हुन्छ। स्ट्रेन भनेको भोल्युमेट्रिक स्ट्रेन हुन्छ, डेल बी बाई बी। यो एक्सप्रेसन यहाँ हामीले युटिलाइज गर्यौँ, एन्ड देन डेल पी टाइम्स डेल पी स्क्वायर हुन्छ। र फ्लुइड प्रेसरको कुरा गर्दैछु त्यसो भए एचडिजी हुन्छ। सो यो एक्सप्रेसन आउँछ, अनि अप्सन 1 मा यो एक्सप्रेसन देखिन्छ, त्यसैले करेक्ट अप्सन अप्सन ए हुन्छ। वेल that was all about question number 7. Now we are here in question number 8. A spring extends by x on loading, then the energy stored by the spring under tension T is, force constant of the spring is K. So as we know that energy stored while extension is F times extension, and also we have extension, so this is tension, so it can be written as T times X. Also we have that the expression F equal to Kx, or it can be written in terms of tension as K times X. So X can be written as T by K, on using this expression here, we can get probable answer T by K. So 1 by 2 T square by K. Let me check. 1 by 2, 1 by 2. This is T square by K. So our option B is correct option. Now here we are going to discuss question number 9. If elastic limit of a rock is this much, what is the maximum height of the mountain on earth? Density of the rock this. Okay, so here we have to analyze this as the pressure exerted by this rock, uh, mountain must be held by this crust. Okay, so we have to find out the elastic limit of this rock. Okay, so it is given to find out height here, so we are going to use the pressure HdZ as formula. So this is our maximum stress, and this is the expression of stress. So HdZ equal to del P, yeah, and its value is 3.0 into 10 power 8 Newton, sorry, on calculation. Okay, so uh, we have to find here H, that's why this is D and Z. Density of rock is provided. Okay, so 3.0 into 10 power 8 by D. Density is 3 into 10 power 3, and we are going to use Z as suppose 10, so its value will be 3 is minus 4, because 3 and 1 makes here 4. 3, I'm going to cancel out, so it will be like 1 into 10 power 4 meter, which means this is 10,000 kilometer, right? Okay, fair actually one. If elastic limit of rock is this much, what is the maximum height of the mountain on the earth? Density of rock दिएको छ, हामीले assumption के गर्यो भने यहाँ यसको माउन्टेन को हाइट जति बढ्दै जान्छ त्यति धेरै प्रेसर यहाँ रकमा लगाउँछ हैन, यहाँ भएको रकमा लगाउँछ। त्यसो भए यो रकमा जुन चेन्ज अफ प्रेसर हुन्छ त्यसैलाई हामीले के भन्न सक्छौं, यसको इलास्टिक लिमिट or maximum stress. So height दिएको छ, डेन्सिटी छ, and then after ग्राभिटी अफ कोर्स छ भने हामीले चेन्ज अफ प्रेसर भन्ने सेन्समा यसलाई एचडीजी रिलेसन अप्लाई गरेको छौं, र त्यहाँबाट हामीले हाइट अफ द रक निकाल्छौं, र यहाँबाट आउँछ रिजल्ट 10 किलोमिटर भनेपछि 10 किलोमिटर भन्दा बढी हाइट भएको माउन्टेन यो क्याल्कुलेसनले देखाउँछ होल्ड गर्न सक्दैन अर्थको क्रस्टमा भएको रक्सहरुले, ठीक छ। ओके, the breaking force for a wire depends on question number 10. Breaking force, अब यसलाई डिस्कसन गर्नुभन्दा पहिला हामीले बुझ्नु के पर्छ भने ब्रेकिङ फोर्स भनेपछि दुईटा प्यारामिटरमा हामीलाई इजिली थाहा छ, दुईटा प्यारामिटर लेन्थ जतिसुकै होस् त्यसले इम्प्याक्ट गर्दैन, हामी यहाँ एलिमिनेसन मेथड फलो गर्दैछौं। लेन्थ जे जति भए पनि त्यसले कुनै इम्प्याक्ट गर्दैन, लेन्थले यो ब्रेकिङ फोर्सलाई कुनै रोल प्ले गर्दैन। सेपको कुरा गर्ने हो भने सेप जस्तो भए पनि त्यसले फरक पर्दैन। अब कुरा आउँछ मेटेरियल, यस अफ कोर्स मेटेरियल डिफरेन्ट भयो, यङ्स मोडुलस डिफरेन्ट हुन्छ, यङ्स मोडुलस डिफरेन्ट हुँदाखेरि ब्रेकिङ फोर्स पनि डिफरेन्ट हुन्छ, किनभने यङ्स मोडुलसको कुरा हामीले गर्दाखेरि स्लोपको कुरा हामी फर्स्ट क्वेसनमा डिस्कसन गरेको छ, जसको यङ्स मोडुलस कम, त्यसमा बडी अर्थ छिटो एक्सटेन्सन हुन्छ, अनि थोरै फोर्स अप्लाई गर्दाखेरि इजिली ब्रेकिङ पोइन्टसम्म हामी पुग्न सक्छौं। एन्ड देन आफ्टर रेडियसको कुरा पनि गर्नुपर्छ। रेडियस किन भन्दाखेरि जति सानो रेडियस भयो, हामीले अघि डिस्कसन गर्यो, एक्सटेन्सन इज इन्भर्सली प्रोपोर्सनल r to the power 4, जति सानो रेडियस त्यति धेरै एक्सटेन्सन र त्यति थोरै फोर्स लगाएर हामीले इजिली ब्रेक गर्न सक्छौं। छ त्यसलाई अप्सन ए एन्ड अप्सन सी यहाँ करेक्ट अप्सन देखिन्छ. Well, this is all about the elasticity, and this is second part of this portion. So uh, we are going to prepare more and more uh, solution for MCQ, so that uh, the students who are studying in 11, 12, and who are going to prepare for different entrance can find some solution, and this kind of our work will be helpful for them. Okay, so please subscribe and please stay tuned. यो हामीले सानो एउटा प्रयास गर्दैछौँ सबैलाई हेल्प गर्न. 11 जसमा एमसिक्यूको प्रब्लमहरू हुन्छ तिनीहरूलाई हेल्प हुन्छ, 11लाई हेल्प हुने हो. एमसिक्यू क्वेसन्सहरू अहिलेको सिलेबसले क्वेसन 11 क्वेसन एमसिक्यू राख्छ नै. 12 पढ्दै गरेकाहरूको लागि पनि 12 सँगसँगै प्रिपेरेसन एमसिक्यू प्रिपेरेसन गर्दै इन्ट्रान्सको लागि पनि हेल्पफुल हुन्छ होइन. 11 देखि नै इन्ट्रान्स प्रिपेरेसन गर्छु भन्दा पनि यो भिडियोजहरूले हेल्पफुल हुँदै जान्छ होइन. अनि अब इन्ट्रान्स प्रिपेरेसन गर्दै गरेकाहरूलाई पनि धेरै हेल्पफुल हुन्छ, हामी त्यही आशा गर्छौँ होइन. सो keep supporting us. Okay, thank you for watching and stay tuned.